Hello everyone. This is the video lecture for College Algebra, Math 1414, Section 2.7, Inverses. Inverses. So, what are inverses? Let's just do a small little recap on this. Not a recap, a first cap on inverses. When I think inverses, I think opposites. That's what comes to mind. Inverses, opposites, reflections, maybe, something kind of like that. In graphical land, let's say that I have, I don't know, some kind of graph like that. Well, an inverse is going to be reflective about this 45-degree line, about the y equals x line. And so reflections kind of mean like mirrors, and it's a mirror image on either side of that line. You would say this is my f, and this is f inverse. Let me re-say that a little bit better. So that's f inverse of x. F inverse of x. Okay. It has a little -1. It just indicates that it's the inverse. So if you see a little -1, it means inverse. Cool. So that's what a graph of an inverse is. I want to show you a math side first. So 2, 7, 3. Here we go. I got f of x is equal to 9x plus 2. And they say that g of x is equal to x minus 2 divided by 9. And they're going to ask, are these inverses of one another? Remember, inverses are opposites. And so I want to know, are they opposites of one another? I'm going to describe in more English for you. I have a multiply by 9. Now I have a divide by 9. See how they're opposites? I have a plus 2. Now I have a minus 2. Plus, minus, opposites. Here's another one you might not have thought. Notice that the 2 is all by himself. Now 2 is kind of like inside. It was outside, now it's inside. The 9 was only with the 9. Now 9 is for everybody. Opposites in every way possible. Are these inverses? I'm going to say yes. But that is okay. If you want to do what I just did and just say yes, that's fine. Do that, because I do that on many problems. Now, I'm going to show you the real way to do it, I guess. And this particular problem is going to lead you down that road anyways. So let's go with f of g of x. Find f of g of x. So I'm going to take this and I'm going to plug it in right there. So I got 9 times x minus 2 over 9, and then plus 2. And I want to simplify this and see what I get. Well, the 9's cancel. The 2's cancel, leaving me with just x. That's it, just x. And so this is an indicator that, yes, they are inverses. So let me give you a formula. F of g of x is equal to x, then they are inverses of one another. Okay? It's kind of weird, but I'm kind of saying f of f inverse of x is equal to x. Notice that f and f inverse should cancel one another, leaving just x. So that's the theoretical side of things. And so that's your answer to part A. And then they're wanting to do the same thing, g of f of x. And you're going to put an x in there because you already know it's going to be that way. And they're going to say inverses. This is part C now. And you're going to say yes. A, B, C. There you go. They're trying to show you, I guess, the long way. And that's fine, I guess. Let's do another one. 275. Now, here's the thing with this one. This one we're going to take a little bit of time on. I've got 2x minus 8, and then I've got the x plus 2 over 8. Are they inverses? Well, I have a minus 8 and then a divide by 8. Okay, I got a multiply by 2. Now I have a plus 2. They're not opposites in that way. I should have multiply, divide. I should have add, subtract. These are not inverses. And I hope that you can at least see that without having to do any math. Now, can you do math for the other one? Sure. But this one here, if there's something that doesn't even look fine, then no, they're not inverses. Now, if it were just that easy for this problem, then I would be very happy. No, no, no. Part A, they still want f of g of x. Now, we are not going to get just x. Wow, I just made my x bigger. We're not going to get just x here. We're going to get something else entirely, and that's the part that makes it harder. I'd say this is probably the hardest question that we're going to do on this section. So it's not that hard, honestly. What I want to do is I'm going to take my g and plug it in to x right there. So I got 2 times x plus 2 over 8, and then minus the 8. I need to simplify this. The first thing I'm going to do is distribute the 2 to both the top terms. 2x plus 4 all over 8, and then minus 8. Now, I want a common denominator because, well, we need a common denominator. So I'm going to say, let's multiply this guy by 8 over 8. Now, I'm choosing that 8 right there because of this guy, not because of this one. I don't care what that number is. It could have been 7. It doesn't matter. But I chose this 8 over 8 because of this 8 right here. Well, notice that I have these 8s here in the top make a 64. Common denominator. So you combine the numerators. I got 2x minus 60 all over 8. And we could still simplify that by canceling a 2 everywhere. X minus 30 over 4. That is the final answer. Whew, that took a long time. Not equal to x. Not an inverse. You should have got just a plain old x there. But we didn't, so therefore not inverses. Now we actually have to do it the other way too, and there's going to be a whole different problem. So I'm going to take this and plug it in there. So I'm going to say now 2x minus the 8 plus the 2, and then divided by 8. Well, this one's much easier. Notice that we have the numerator here. We'll make a negative 6. Cancel 2's everywhere. There we go. Again, not equal to x, so it's not an inverse. Okay, so hey, are these inverses? No! A, B, C. Okay. And that's the hardest problem that we'll have to do. Everything else is actually easy. I might have lied. I don't know. So 2.7, 2.7.15, I have f of x is equal to... Didn't we just do that problem? I'm going to do something very similar. 3x plus 2. Mine has 9x plus 2. And because it just looks like something we just did. And they want to say, find the inverse. Okay. Notice that this time I'm not given an inverse and saying, like, comparing them. I need to find the inverse. So I'm going to do this the short way first. I'm going to say, you know what? I know this problem. Look, look, look. I got a plus 2. So guess what? Minus 2. I got to multiply by 3, so now I got to divide by 3. Notice again, multiply by only x, now divide by everybody. And now finally, plus 2 on the outside, it's going to be a minus 2 on the inside. That's it. That's it. That's your answer. Ta-da! Well, I want to do this the long way because if it were always this easy every single time, well, that would be pretty cool. It won't. So I want to show you the longer version on something simpler than, you know, more simple. Simpler, simple, more simple, more simpler. So let's do it the long way. I'm going to give you steps to finding an inverse. Steps. Step number 1 is I got to put a 1 there, of course. Step number 1, I'm going to set this equal to y. Now that sounds kind of weird, but this I'm going to use a different color. This original here, that f of x, is basically a y, so I'm saying y is equal to 3x plus 2. Okay, cool. That's what I was meaning. It's a pretty easy step. Just make sure it's a y in there instead of f of x. Number 2, I'm going to switch my x and y around. So wherever I have an x, I now have a y, and wherever I have a y, I now have an x. You see it? I didn't actually do any math here. No math. Wherever there's a y, put an x. Wherever there's an x, you put a y. No math, no math. Step number 3, solve for y. That's it. So now this is actually the real math. I need to get y by itself. I'm going to first off minus 2 on both sides. Then I'm going to divide by 3. And that is your inverse. Didn't we just have that a couple minutes ago? You can see that there is a strength to having it just look at it and get the answer. There's a good thing here. This is not wrong to do this. But not every single problem is going to be that easy. So going through these steps and motions is good now. Let's do another one, 2717. So I got f of x is equal to x cubed plus 5. Find the inverse. So I think it's pretty obvious that the opposite of plus 5 is minus 5. Cool. So I got x minus 5 somehow. I don't really know. But now I have this cube. What's the opposite of cube? Is cube root. Just like square and square root, cube and cube root. Now here's the one more thing. I'm only cubing the x. Now I'm cubing everything. Well, cube rooting everything. Or you could say that the 5 was on the outside. Now he's on the inside. Opposites in every way possible. That's your answer. Now let me do the long road. Y equals x cubed plus the 5. I'm going to switch my x and y around. And so then I got, and then I'm going to solve. So I've got, let's minus 5 on both sides. X minus 5 is equal to y cubed. Cube root. To get rid of that cube, you cube root both sides. Remember, and I think I told you this, maybe not. Whenever you cube root, it's only the positive. There's no plus and minus for that, okay? Square root for sure, plus and minus. Cube root, no. Just the single, and that is your answer. That's your inverse. And we just had that a second ago. All right. Next problem. Nope, sorry. 2725. I've got f of x is equal to x plus 6 all divided by x minus 3. Find the inverse. All right, come on. What's the opposite? Right, I got a plus 6, and then I got a minus 6. I got a minus 3, and I got a plus 3, and I got a division. No. It doesn't work like that. You see, it's really cool to be able to just look at the opposites of the easier ones, but when you have something like this, or anything complicated at all, we need the steps. We need the steps to be able to solve this thing. And so I'm going to do just that. Y equals x plus 6 over x minus 3. I'm going to switch. So now I got x is equal to y plus 6 and y minus 3. Now, whoa. I've got a lot of y's now. Kind of scary. But you know what? We're going to do this thing. Solve. Okay. I got a question for you. Do you like fractions? Do you like fractions? Most of y'all are going to say no. I'm assuming no. So I want to get rid of this fraction. I want to make it so that it looks easier. So I'm going to move this to the other side. I'm going to multiply it to the other side. So it looks like this. See, no more fraction. That's good. Distribute your x. So xy minus 3x is equal to y plus 6. And remember what we're looking for here. I guess I'll go back to black here. What we're looking for is I want to get y by itself. Like y equals. What if I minus 6 on both sides? Okay. What if I minus xy on both sides? Who knows if I'm doing this right? Notice that I have y's on one side now. What I'm going to do is I'm going to factor a y out from both of those to the front right here. They both have a y. Remember, this is a 1y, so I leave a 1 behind. And I want y by itself. I'm so close, I'm going to divide this to the other side. And we finally have our answer. Now, that took forever. It didn't really. That's your answer. That's your inverse. Wow. There's a lot of minus signs, a lot of flippy stuff going on. Could you have taken this and somehow gotten this? The answer is maybe. The answer is maybe. Let me rewrite it for you. So I'm going to do f of x, actually. This does not apply every time, but over the years, I've found that there is a way to see all this. Now, what I'm going to do to this is I'm going to say, factor out a minus sign to the front in the top. And then this guy, I'm going to factor a minus sign to the front as well by swapping them. What you actually get is a lot more plus signs than you think. Only one little negative down there. These are still inverses, and these are identical to one another. Okay? Cool, cool. Look back and forth for a couple minutes. Maybe seconds. Do you see some kind of commonality? Some kind of opposites thing? Back and forth and back and forth and back and forth and back and forth. Back and forth. Back and forth. It does not always work like that, but I'm just making a point here that randomization in my math lab is not the best thing. So, moving on, I got f of f inverse of x is equal to what? And then they say f inverse of f of x is equal to what? This is kind of like a part B to this problem. Well, you're going to put an x in there. The thing is, they don't just ask for this, because then, this is the indicator. Are they inverses? And you're going to say yes. They want more than just that. Let me rewrite this. They're going to do this. F of f inverse of x is equal to f of blank equals blank. And then they similarly confuse you by doing it all over again for no reason at all. Now, I know that these answers are x, but what goes in here? Notice that this was the inverse, so you're literally just rewriting your inverse in there. 3x plus 6 over x minus 1. And then here, this was the original. So I need to just literally rewrite the original. Here we go, x plus 6 over x minus 1, 3. This is the inverse. You're just copying it. And this is the original. You're just copying it. And then these guys are always x's. Watch out for that part B. So many folks have gotten part A correct. Nice. And then all this is messed up. Because what are they asking for? It's very confusing. Oh, I actually have another problem like this. Super cool. So here's another one. 2, 7, 27. I'm just going to do this part. F of x is equal to 2x plus 1 all divided by x minus 3. And they're saying, hey, find the inverse. So we would go through all the steps and stuff. Can you see the inverse? Can you see it? I'm just going to do it the long way to make you sad. Skip ahead about 5 minutes, 10 minutes. So, how are you enjoying the class? Is it a good class? Pretty interesting, right? Lots of math we're doing every day. I hope that these recordings are beneficial to you, because I certainly am taking a lot of time to do them. I do like them. I think that it's good to have this sort of record of how to do these problems. And it's a good reference tool for studying and heck, even going on to other classes. Though I don't know if I'm going to post these on YouTube sometime. Maybe. Maybe years to come. If you like this and you want this on YouTube, you can tell me and I'll reply to you. I don't know if I'll actually answer with a positive, but I would answer the email you send me. Okay. There's your answer. Could you have gotten that about 5 minutes ago? Yeah. But I'm not going to show you because I'm trying to be a good teacher. Next question. Actually, they're going to go on to a new topic here. Kinda. We're going to do some graphs of inverses. Now, first off, we just need to know, does an inverse graph even exist? Let me use a different color. So they got this cubic thingy. And they're saying, does an inverse even exist for this guy? There are some functions that do not have inverses. I mean, we saw that on question number 2, actually. It was, well, actually, you could have had an inverse, but those two were not technically inverses. I'm saying that, is there any inverse possible that I can use here? And I'm going to say here for this one, no. And I'm going to tell you why. Remember the vertical line test where we run vertical lines and see function because once, everything's fine? Well, similarly, there's a horizontal line test where if you ran horizontal lines, let's say with, I don't know, the square root function, once, everything's once. So yes, there is some kind of inverse for this. And you know what that inverse would look like? It looks like this because it's mirrored, it's reflected about this 45-degree line. The y equals x line. So that way you can just look at it. You can draw it for yourself. What would the inverse of this be? It doesn't exist. That's the thing. It doesn't. There's no way. So horizontal line test, I run one horizontal line, and you can see I'm touching it more than just once. No inverse. Again, what would this even look like if we're trying to make an inverse? You can't. You can't. That's the point. Here, let me try. So, like, okay, this guy's doing this thing, and I'm already confused. Don't do this at home. Don't do this at home. There we go. I guess. Let me try that again. I think I got the idea now. Okay, I think I got it. Okay, don't try this at home. This is just me just showing you what's going on here, I guess. Okay, that would be my inverse, if I could say that was an inverse. We'll run a vertical line test. It's not even a function. Remember, inverses are f inverse of x. F, function. Is this right here? Is that a function? No, it doesn't even pass vertical line test. No. Sadly, that was our very first question, because all the others are yes. 2, 7, 33. So I have this, it looks like it goes down. Does this, and it says, does an inverse exist for this? Can you draw an inverse? I would say yes. Horizontal line test once. It is once there. It's just my drawing is not very good. And so what would that look like? It would kind of look like this here. Let me try that again. No. Yes. Something like that. Something like that. Anyways, the answer is yes. All right. 2, 7, 35. I got this line here. It actually goes through at -3 and at +9. And then there's a line that goes through these like this, like a line, like a straight line. And they're saying, graph the inverse. What would the inverse look like? And you're going to have multiple choice, A, B, C, or D. Well, 45 degrees is right here. And if I were to mirror image this, it would look something kind of like that. Again, mirror image. You would be colliding here at -3 and over here at 9. Notice again, mirror image, right? Whatever's on this side is on that side. You ever look at the mirror? You ever look at the mirror and you see yourself? And so you back up from the mirror? Well, then the other person on the other side's backing up. If you get really close to the mirror, the other person on the other side's like really close to the mirror. When you touch the mirror, the other person on the other side is touching the mirror. Right? Touching. Far away. Close. Okay. I have other jokes, but whatever. It's better in person. Much better in person. Makes you want to take a lecture class with me, right? Anyway, so that's F. This is F inverse. Moving on. Same thing here. They give me a graph. It looks like an exponential, which we'll be seeing here soon. And they say, what's the inverse look like? Graph the inverse. Not just is there an inverse, but graph it. I guess they're assuming that it does work. 45 degrees, something kind of like this here. That would be a logarithm. But again, we'll see that another day. F inverse. Cool. Graphs are so fun. They're so easy. Or at least they're not too bad. I like the multiple choice aspect. We got 6x minus 8, and they say, find the inverse. And then they want you to graph them. Again, not hard at all. I have a multiply by 6. I'm going to divide by 6. I have an x minus 8, and I'm going to have an x plus 8. Notice that he was on the outside, now he's on the inside. This is only for x, now it's for the whole thing. So what does this look like? 1, 2, 3, 4, 5, 6, 7, 8, and then a 6. We already had a whole chapter on, or a whole section on graphing lines. You know, rise 8 over 1. Not the best to scale, but hope you're seeing what I'm seeing. And then we got my 45-degree line. And then I want the graph of the inverse. So right here, they're touching, and then they go far away, far away. Could you guess where it's colliding right here? Yep, at -8. Wow. Go figure. And that's your F inverse. Okay. 2, 7, 41. I have f of x is equal to x squared minus 15. And then they say x greater than or equal to 0. Find the inverse. Okay, whoa. Let's talk, because this one's a different one, okay? It's not really that big. Y equals x squared minus 15. I'm going to switch them. X equals y squared minus 15. And then I'm going to solve for y. Let's move the 15 to the other side with a plus sign. And then how do you get rid of a square? Well, you square root both sides. Of course. But whenever you square root both sides, remember plus and minus. Square root, plus and minus. Cube root, whatever, plus. But a square root is plus and minus. I cannot give you a single one answer for this. It won't work. I'll show you graphically what's going on. Here's the graphical side of things, okay? So my original is the x squared minus 15. So 15 down here, and then I have this parabola. Sorry, I'm doing this graphing tablet on my lap, so you're wondering why it's always like the worst thing ever. I can actually do much better on a whiteboard. Okay, that's my 45-degree line, and I need to draw the inverse of that. Well, they're touching. 15, 15, somewhere over here, negative 15. And so it looks kind of like this, actually. There you go. Looking at the black, I'm going to ask, is the black right here, is that a function? This is back in chapter 2.1, basically. One vertical line? Nope. Touching it twice, so no inverse possible for a plus and a minus. But here's the thing. Go back up. They gave us this domain restriction. They said, hey, we're only looking at the positive side. So if I were to go back here and look at this, they're saying only the positive side. So I'm going to erase this. Erase. Eerie. That's the only graph that I'm looking at. Well, what's the opposite of that graph? Well, it's this black line up there. So erase the other one. Eerie. Okay. Is this right here, just this one black line, is that an inverse? Well, look, it's only touching one time. It is an inverse now. It works. It's a function. We're great. Everything's happy. You only touch once. Once. Everything's fine. As long as it's only positive. And I have to eliminate that just because they gave us that domain restriction. And so therefore now, you would just put the positive. Now that was a whole lot of talking for just opposite, make sure there's a plus sign in the front. I understand. But that's why we're doing this, to learn, not just to answer homework questions. I think that this is the last question I have. Now, this question's a lot different than all the other questions. It's going to take me a second here to copy this down, okay? I also have multiple questions for this. I call this problem the hopscotch problem. While I'm in a physical class, I actually jump around the classroom as if I'm doing hopscotch. Because it's fun that way. We don't actually play hopscotch. I honestly don't really know how to play hopscotch. I just know what it looks like. It's little squares on the concrete that you draw with the chalk, and you're jumping from one number to the next, that kind of thing. Well, I say hopscotch because we're hopping around back and forth. That's going to be what we do here. So, hopscotch. Here we go. I got f of g of 8 is equal to what? Now, I can go super technical on you, but I'm just going to go straight in the hopscotch method, and it's very simple. Start with an 8. Where's your 8? Oh, right there. So, dun, dun, dun. It's like I'm jumping. I'm trying to jump. Dun, dun, dun. Well, now I'm looking around for the next number, and it's going to be -5. Where's -5 around here? I already used that one. Where's another one? Oh, right here, right here. Dun, dun, dun. And then I jump to the next one. Dun, dun, dun. That's it. Start with the 8, jump, find the other one, jump again. That is it. There's nothing else. I'm going to do a couple more just so that you can see all the variations they're going to do. So notice that we had started with G anyways, but now they're going to swap them. See how they're swapping them now? They're saying, hey, G of F of 5. There might be multiple 5s, who knows? But here I'm starting with F. F is on the inside. Again, G of F of 5. It looks like that. I'm starting with the F right here. Dun, dun, dun. Look for the other one over here. Dun, dun, dun. Very simple. Let's do one more. Let me use a green color. So I got F inverse of G of 4. Well, notice that we're starting with G of 4 right here. Dun, dun, dun. Now, -1, if I were to go back this way, notice that I have a little inverse here. What that's trying to say is that we're going backwards. And in hopscotch, you can actually jump backwards. I would demonstrate that physically, but I can't. So, dun, dun, dun. Notice that what I did here, I jumped backwards to get to this one. Normally it's always forwards, but this guy was a backwards, and they had told me, hey, you need to be able to go backwards. 2. Again, there's a whole lot more technical stuff going on behind the scenes, but I really like this. I think it's easy, and, well, that's the end of my story. So we're done. We're done with that chapter. Super cool. If you have any questions, let me know. Thank you very much, and have a great day.